Right, this is exercise 14b for year 13 students, just finishing off their A-level. Newton-Raphson method is a nice little method to solve equations which otherwise we couldn't solve. So we've seen a couple of these methods before. One was digital, or like some kind of decimal search where you use a change of sign method, for instance. But this is a more sophisticated version of that. Okay, so we'll have a look at this. This is the Newton-Raphson method. Newton, by the way, is this guy here, so Isaac Newton. And Raphson was someone at the same time. And basically, Raphson used the method. He was the one who published the method that Newton had first thought of. So, oops. Let's have a go then. So this starter, obviously, this is a decimal search method. What you're meant to do on this starter is show that there is a solution between 2 and 3, and this is change of sign method. That's the way you do it. You'll notice it's you've got an equation that's equal to 0. If you put 2 in, you get -10. If you put 3 in, you get 220. It's the change of sign that basically tells you there's this a solution between the two, and we've seen that in previous lessons. Now this at the top was meant to say Newton-Raphson method. It's just been missed off, but this is basically the idea of it. Now what we've got is a curve. Now that, I suppose, is the equivalent of this thing here. On this equation I've got a function, and we want to see when it is equal to 0. That's really what we're trying to do. So here is my made up function here, this blue line. And we're trying to find the point where it equals 0, the point where it crosses the x-axis. So you obviously don't know what it is. So anyway, this is Newton-Raphson's method. So if we have a go at it, it basically uses a tangent, it says, and bit by bit it improves the accuracy of our guess. So that's my first guess. I've called it x1, and we pop x1 into the function, and then effectively I draw a line from it, which is meant to be, I'm not convinced it's great, but that's meant to be the tangent. This line here is meant to be the tangent at this point, the tangent to the curve. And what you'll notice is it hits at some point this line over here, and that gives me my second guess. And x2 then gets put into the function. You can't quite see it on the screen here, but it just goes off the edge, but it hits the function. And so where it hits the function, I draw a tangent. Oops, wrong one. There's the tangent to the curve. Oh, and notice what's happened is it's much closer now where it hits. It hits there, which is going to be called x3. You draw a line, you draw a tangent, and now we're pretty damn close to it. So we're at the point now where we can say, you know what, x4 is the root. And so this then is the formula that we're meant to use, and you can prove this formula, and we don't need to do that here now. We're just going to use this formula. And notice it's an iterative form like we've seen before, but it involves differentiation. That's why this is a bit more sophisticated than other methods. Got a differentiation there, f-x. And it basically says the next root, this is the next guess as to what the root is. Guess is not the best word, but the next iteration, it relies on the last one. This is the last one, the value of the last one. That's an L. And we basically have to put that xn in both to the function and into the differentiated version of the function. So there's definitely a bit more maths involved. So let's do this is the proof, which if anybody wants, you can have a look at. I'll just show it so you can see it properly. But I don't really want to do that now. I just really, for now, want to go and do a couple of questions. So first of all, it says sketch the graph of y x to the 5 minus 5x. Well, it's x to the 5. So that's the graph. So you can just see it goes up, it comes down, and So you notice there's 3 places where it hits the 0 line. There and there, and one of these is what it's going to want me to find, and it says right, it wants me to start with x1 equal to 2. So if x1 equal to 2, well, I'm assuming, it doesn't really show you, but I'm assuming 2 is here, and we're going to try to find the value where it crosses. It looks to me between 1 and 2, but my graph, I'm not exactly sure what it is, so who knows. So anyway, going back to here, here's the function. So first of all, I write x1 equals 2. And to get x2, I'm going to have to first of all do f dash of x. So obviously f of x is meant to be x to 5 minus 5x plus 3. That's what my function is, because it tells me that up there. And if I differentiate that, I get 5x to the 4 minus 5. So when x1 equals 2, the best way to do this is to type, I mean, if it was me, I'd go 2 and equals on my calculator. And then I would go answer minus the function. So I've got to go answer to the 5 minus 5 times the answer plus 3. You might be good at doing these iterative sequences on your calculator, but you might not be. So 5 times the answer to the 4 minus 5. So if I type all this in, it should give me then the second value of x2. So I'm doing it now. So 2 equals, and then answer minus fraction button, answer to the power 5 minus 5 times the answer I'm pressing the wrong button too. Got there eventually. And then 5 times answer to the power 4 minus 5. So what do I get? I get the answer 5/3, 1.67-ish. So that kind of fits in with what I was doing on that picture just now. So I get x2 equals 5/3, and it says, I'm going to write it says down to 2 dp, so that's 1.67. The next one says 1.44. The great thing about this method is you just press equals again and you just get your next answer, and press it again. I get 1.32. Seems to be getting closer and closer. 1.28. And usually they say to write these answers down. Sometimes they just say what's the answer and just show a bit of work out, maybe do the first few. So I'm going to press answer lots of times, or equals lots of times, and you know what? After lots of goes, you still get that. So alpha is often used to represent the root. So I'm going to do that. I think the answer is 1.28. Let's see what my answer was to last time. Yes. And notice I've said this one converges to the root. So that we did get an answer. And bear in mind, we don't always get an answer. So this time I've got exactly the same thing. What's it look like? You can just see that on the next slide. Okay then, it seems to only have one solution down here somewhere near -2, and you could use your calculators to work that out, but it says assume that the first answer is -5. So okay, so we've sketched it. I need to differentiate it. I've got a function, so f dash x equals, now it becomes 3x squared divided by 3, so presumably it's just x squared minus 1. And so again, I'm going to chuck x1 equal to -5, and I'm going to try and type this in properly this time. So I'm going to -5 on my calculator using the negative button, and then I've got to do -5. Oh, that's right. That's me being stupid. Answer minus the function. So I'll press the fraction button. And I've got to do a third. I've got a fraction on top of it, on the top half of a fraction of answer cubed minus the answer plus 2, and that's all over. What was it again? It was x squared. So answer squared minus 1. And hopefully it will give me, I'll get -32/9. So we'll check in a bit what the answer should be. Now, what is that? When I press the SD button, I get -3.56. It wants 3dp this time, so 3, 5, 6. And to keep pressing equals, I got minus 2.74, press it again, minus 2.41, and I'm just pressing it lots of times now, and eventually this gives me, and again you have to read the question because it might, so xn plus 1, or if you prefer alpha, the root is minus 2.355. That's what I get anyway. Good. And oh, by the way, what's it say? There was what happens if I take? Oh right, if you start somewhere else, it seems that if you go with x1, you can try that as well. Put 0.5 in as your starting point rather than minus 5. See if it goes to the same place. It doesn't always work like that, so that's what that question's about. So show that this interval has a root in the. So this equation has a root in the interval 0 and 1. So what I would do here, if I was doing this question, my first thought is write f of x equals to the x to the 4 minus 7x cubed plus 1, and I put f of 0 in and I get 1, and I put f of 1 in and I get 1 minus 7 plus 1, which sounds to me like minus 5, and there's a change of sign which I can't be bothered writing, therefore we have a root, and that's what that first bit's about. Use Newton-Raphson. Well, if I'm going to use Newton-Raphson I need f dash x, and that's obviously 4x cubed minus 21x squared, and therefore I can chuck, what does it say, x1 equals 1 as my first number, so x2 then, and again just using the answer button, start off with 1 equals, always remember that step, otherwise you end up typing a lot, and it's answer minus fraction button, and the f, so I get answer to the 4 minus 7 times the answer to the power 3 plus 1, and that's over, what was the f dash again? I'm just looking for it. Did I find f dash? Yes I did. So it's 4 times the answer to the power 3 minus 21 times the answer squared. I'm hoping that gives me the right answer. I got 12/17, which is 0.706. And again it says use it, so you're meant to do it usually to show a couple of answers. So 0.57 wants 3 decimal places, so 572, and after a while usually you just jump, and 537 it seems to be 0.537. It does ask, why is x1 equal to 0 not a suitable starting point? And if we just have a look at this, my guess is it's a turning point, it's a stationary point. So let's have a look at the graph. Have I drawn the graph? Yeah, yeah, there it is. So the answer to the last bit will be, it's no good drawing that there. If you remember I said you draw a tangent to it. Now the tangent to this goes straight across. So it fails miserably there, because the whole point of the tangent, it's got to cross somewhere, it's got to cross down here. Now if it doesn't cross, like this one, it goes straight on. You won't ever get anywhere with that. So anyway, 0.537 is there, yes. Now with this last one, it's actually a better equation, this. So I'm going to pause this, I'm going to do a bit of work on the screen so you can see it, and then come back to this question. Yeah, so well, I'll put the numbers into the calculator, and there's obviously f of minus 1 is negative, f of 0 is positive, so there's must be a root in between these two. Again, between 0 and 1 there's got to be another root, because one's positive, one's negative, and the other one I found was here, between 3 and 4. Now it wants me actually to find all of them. I'm not going to do that, but you know, if you go through this process, don't forget when you differentiate e to the x, you still get e to the x. When I differentiate minus 3x squared, I get minus 6x. I like this question because there's no way physically, there's no algebraic method to do that without this method, so I much prefer this. They were my 3 answers, by the way. Ooh, lost them. And so your job will be to have a go at these exercises which I'm going to put up for you there. Have a go at those for me. I'll put the exercise on Moodle as well, and then with any luck we can start filling some of these gaps which we've been left by this mess of a situation. So all the best and good luck.